Use the quotient rule for exponents. So let's consider x to the fifth over x squared. What does that mean? Well, x to the fifth is saying we have x times itself 5 times. And x squared is saying we have x times itself twice. Well, if I cross out an x and an x, right, they cancel each other out. X and an x cancel each other out. I'm left with x to the third in the numerator and just 1 in the denominator, which is the same as x to the third. So we started with x to the fifth over x squared, which turns out if we take 5 minus 2, we get x to the third. So when you are dividing with the same base, that's important. Notice that the numerator and the denominator both have a base of x. We can subtract the exponents. That is the key there. Now, before we just jump into two examples, I want to do a little bit more piece here. So first, think about in general, right? If we have the same base, then we take a to the m minus n. It's always numerator subtract the denominator. What if we have y to the third over y to the third? Well, what does that mean? Same idea of 3 minus 3 is y to the 0. Well, think about, what if I gave you 3 over 3? We know anything over itself is 1. Y to the third over y to the third is anything over itself, which means y to the 0 is the same as 1, which is the same as 3 over 3. So anything to the 0 power is 1. That just comes back to the quotient rule. Let's do some examples. Y to the 12th over y to the 7th. Well, I have the same base, so my base stays the same. I take the numerator exponent and subtract the denominator exponent. So I end up with y to the 5th. In letter B, I have 7 to the 5th over 7 to the 3rd. Base of 7, so 7 stays the same. Numerator exponent first, minus the denominator exponent. So I get 7 squared. We can simplify 7 squared. That's the same as 49, because 7 times 7 is 49. In letter C, you'll see, and C and D, the base is negative. So I have negative 3 in parentheses on the numerator and the denominator. So my base stays the same. I'm going to keep that negative 3 in parentheses. I take the exponent of my numerator, which is a 6, and I subtract the exponent of my denominator, which is a 2. So I have negative 3 to the 4th power. Now to simplify this, this is the same as taking negative 3 times itself 4 times. Well, negative 3 times negative 3 is 9. So this is 9 and this is 9. So I end up with 81. 4 negatives gives me a positive. And last but not least, I have negative 2 to the 8th over negative 2 to the 5th. So my base of negative 2 stays in parentheses. My exponent in the numerator is 8. Subtract the exponent of the denominator of 5. And I get negative 2 in parentheses raised to the 3rd power. Well, that's the same as negative 2 times negative 2 times negative 2. 3 negatives, still negative, and 2 times 2 times 2 is 8. So that simplifies to be negative 8.